Welcome back to our discussion to quadratic equations. So now they have given us an example equation that given that the equation y squared plus 3y plus q equals 0, and also that the y squared plus my plus k equals 0. So these are two different quadratic equation, but all of them in terms of y. So now they have a common root. They are saying that they have a common root. So they want us to show that the q minus k squared equals m minus p into bracket, that is pk minus mq. So now what do we do when we come about this equation? What we do, first deal with this and this. So from that solution, that y squared plus py plus q equals 0, that is equation 1. This one is y squared plus my plus k equals 0, that is equation 2. So one is equation 1 and the other one is equation 2. So what we do, we have now to let us subtract equation 1 from equation 2. So say equation 1 minus equation 2. This one will give us that the whole of this thing, when you subtract this one minus this, that will be a 0. So we count this one minus this. So it becomes p y minus my. So then this side it becomes now plus this one minus this. So which becomes that it is q minus k. So that is what we have. So must be equal to the 0. So what we do, let us first bring everything which is this side. We take everything which is this side, this side. So the py and my, we take it the other side of 0. We shall have that q minus a k, q minus k, which will give us that q minus k will give us this side, which is now, when you take a negative this side to become a positive, also the positive will come to be a negative, so it becomes my minus a py. So since y is common, we factorize out the y. So here it becomes q minus k. Q minus k will give us the m minus p, then times that value of y. So we make y now the subject. So that means our y equals y dividing all this side by this one, divide both sides by m minus p. So we shall have that our y is q minus k out of m minus p. So for this one, equation star. So now after getting the equation star, you have either substitute in the first or second equation, you get what they want. So let us put in the first equation, we see what will be the result. So for that case, our first equation is y squared plus py then plus q equals 0. So we put in the value of y which we have got, which is equation star. So that is q minus k out of a minus p, the whole thing squared, then plus p into q minus k out of m minus p, then plus q equals 0. So that's what we have after substituting the values of y. So for this case, we have to, when you have something like this, apply square on each and everything which is in this bracket. So it is q minus k, the whole thing squared out of m minus p, which is a square. So plus this one, which becomes now p p into q minus k out of m minus p. So when we multiplying these fractions, this one multiplies only the one which is up, which is the numerator, but does not multiply the denominator. So now it is plus a q equals 0. So now what we do, we get now the LCM of this one, and this. So now after getting the LCM, we multiply all through by the LCM. So the LCM is m minus p squared, multiply here, so you remain with q minus k, the whole thing squared. So here it becomes plus, multiply, divide this one by this, remain with only one m minus p. So when you multiply this one, it shall be now p. So if we first multiply it inside, it becomes this times this, which is pq minus pk. So times the number after dividing by this to become m minus p. So now it becomes this side plus this one, which is a q into m minus p squared, which is equal to 0. So that's is what we have after getting the LCM and multiplying all 0 by the LCM. So we need to get something like this. So we have this one. What we do, everything which is this side, take it the other side. Everything which is here, you're going to take it on the other side. So for that case, we shall have something like this. So we are taking this on the other side. So, but before we take it to the other side, we have a common term between this one and this. A common term which is m minus p. So we first factorize out, so here we shall have q minus k, the whole thing squared. Q minus k, the whole thing squared. So this one becomes plus. This one is common, so we factorize, which is m minus p. M minus p. So again, multiply by. So there is this one, and this so here we shall remain with p, pq minus pk. So now we have this side, so we shall remain with only one m minus p. So we multiply now the q. So here it becomes plus qm. Then here it becomes minus pq. So since we have a pq and a pq, that one we cancel. We cancel automatically. So here it is equal to 0. So here we shall have that q minus k, the whole thing squared. So plus m minus p. This one now times this one we say is going away. So we shall remain with qm minus a pk. Qm minus a pk. Now remember, this one is equal to 0, but we have to get something like this which is equal to this. So what we do, everything which is here, we take it to the other side. We are taking everything which is here, this side. What we do, we are going to first introduce in a negative here. What you are going to introduce is a negative. What I'm going to do, I'm going to say it is a q minus k, the whole thing squared. So here it will be a plus, but I'm going to introduce a negative so that it can change these ones. This one change the signs. So by introducing the negative, I mean, so this one will be negative into m minus p. So that means I'm factorizing out the negative from this one. Factorizing out the negative to be n minus p into p minus k. No, it is pk minus q m, or can call it mq to fit with the other scenario which they say, which is mq. So when I factorize this in negative, I have this. So that when I multiply it back, I have something like this. Now what I do equals 0. Since a positive, when you add a positive plus a positive, or when you multiply positive and a negative, or when you add the negative and positive, you get a negative, I'll have that my q minus k, the whole thing squared, then minus m minus p, then times pk minus m q equals 0. What I do, I bring everything which is here, I take it the other side, so I will have that the q minus k, everything squared, equals m minus p, then times pk minus mq. So I've taken everything which is here this side. So that's what we shall have after the end of this expression, by showing this one is equal to that. Since we have seen that this one is the same as what we have got here, so we say as required. So from there now we conclude that this one is the same as that. I think everything was clear. So we are going to stop from here with discussion about quadratic equations. Thank you.